Hello students, in this video we are going to discuss some of the important topics of the structure of atom, and these topics are going to be asked in the coming NEET, Karnataka CET and JEE exam. And students, at the end of this session we are going to discuss the most repeatedly asking questions from this chapter. Let us start with the fundamental particles of the atom. As we know, the three fundamental particles are electrons, protons and neutrons. Here we must remember the charge and mass of these three fundamental particles, and the charge of electron is minus 1.6 into 10 to the power of minus 19 coulomb, whereas proton is plus 1.6 into 10 to the power of minus 19 coulomb, and the charge of neutron is 0. And if you see the mass of these subatomic particles or fundamental particles, the mass of electron is 9.1 into 10 to the power of minus 31 kg. Mass of proton is 1.672 into 10 to the power of minus 27 kg, and mass of neutron is 1.675 into 10 to the power of minus 27 kg. If you see clearly, the mass of proton and neutron is almost same. And one more point we need to remember related to this is the relationship between the mass of these fundamental particles. For example, the mass of electron is equal to the mass of proton divided by 1840, which means what? The mass of electron is very much lower than the mass of proton. So mass of electron is less than the mass of proton. Or we can say mass of proton is 1840 times higher than that of mass of electron. And similarly, mass of alpha particle, and alpha particles means, remember, the helium nuclei. Alpha particle means helium nuclei, and the mass of alpha particle is 4 into the mass of neutron, or 4 into the mass of proton, because proton mass and neutron mass is almost the same. So 4 multiplied by either the mass of neutron or either the mass of proton we can take, because helium having 2 protons and 2 neutrons. And likewise, remember the value of 1 electron volt, that is 1.6 into 10 to the power of minus 19 joules. Let us also revise about some of the basic information about this chapter related to atomic number and atomic mass. Atomic number means number of protons present in the atom, or we can consider number of electrons also, represented by symbol Z, whereas atomic mass or mass number is the total number of protons and neutrons in an atom. If we are going to consider X as an atom, at the subscript we are going to represent atomic number, and superscript we are going to represent atomic mass. Similarly, we should remember the meaning of isotopes, isotones and isobar. Isotopes means the elements have same atomic number but different atomic mass. And isobar means they have same atomic mass whereas different atomic number. Here is the example of isotone. Isotone means they have same number of neutrons. If you take one of the isotope of carbon and if you compare with the oxygen mass number, we can find they have the same number of electron. If we use the formula A minus Z to find out the number of neutrons, here in both these elements we can find the same number of neutrons. The next very important topic about electromagnetic spectrum, and we know in electromagnetic spectrum we are going to arrange the electromagnetic radiation in the increasing order of wavelength. Lambda is the symbol of wavelength. According to that, we can find cosmic rays has lowest wavelength and radio wave has the highest wavelength. And if you want to check the relationship between velocity, wavelength and wave number, we have formulas to remember. Mu is equal to C by lambda, where mu is frequency, C is velocity and lambda is wavelength, or lambda is equal to C by frequency. And one more important formula here is to find out wave number, that is mu bar, that is wave number is reciprocal to wavelength, means wave number is inversely proportional to wavelength. This much you have to remember here. Then you know about photoelectric effect, which means when the energy or light falls on the surface of the metal ejects the electron. Now the kinetic energy of that electron we can calculate with a formula. Kinetic energy is equal to half mv square, or energy is equal to h mu minus h mu naught. Here h mu is the normal energy, whereas mu naught means threshold frequency, means minimum energy required for this process, and h mu naught is threshold energy or work function represented by w naught. And another important theory we are going to discuss is Planck's quantum theory, and here it is the amount of energy emits or absorbs by the atom or a molecule, and that energy is directly proportional to frequency mu, or inversely proportional to wavelength. And if we calculate, then we get a formula: E is equal to energy is equal to h mu, or in place of mu we can substitute C by lambda. This is for 1 photon. Remember, it is very important. According to Planck's quantum theory, if you want to calculate the energy of 1 photon, then you have to use this formula: E is equal to hc by lambda. Whereas for n number of photons, if you want to calculate for n number of photon, then you have to use this formula: E is equal to n h mu, or E is equal to n hc by lambda, where h is the Planck's constant. This is the value of Planck's constant. The next topic is hydrogen spectrum, and in hydrogen spectrum you can find so many series or so many lines which are going to arranged according to electromagnetic radiation. Then here we must remember the series names, and along with the region and the value of n1 and n2, which is very, very important. Now the series includes Lyman series, Balmer, Paschen, Brackett and Pfund series, and these are the regions. Lyman comes under UV region, Balmer visible, and Paschen, Brackett and Pfund comes under IR, infrared radiation. And according to the series, we have to remember the value of n1. For Lyman series, n1 value is 1, Balmer is 2, Paschen is 3, Brackett is 4 and Pfund is 5. Similarly, n2 value, it starts with 2, 3 so on. For Balmer 3, 4, Paschen 4, 5, Brackett 5, 6 and Pfund 6, 7, so on. So this we have to remember about this hydrogen spectrum series, region and n1 and n2 value to calculate the numericals. And now for those different series of hydrogen spectrum, to calculate the wavelength or wave number, we have one formula called Rydberg's formula, that is wave number is equal to 1 by, we know wave number is reciprocal to wavelength, or we can calculate as wave number is equal to Rydberg constant RH into 1 by n1 square minus 1 by n2 square into z square. Z is here atomic number, into z square. If you are considering for hydrogen, z value will be 1. So it will remains only this formula to calculate the wave number for hydrogen. And for example, in the exam they are going to ask, for example, for in Balmer series, we want to calculate the n2 value for third line. So we know for Balmer series n1 value is 2, Lyman is 1, Balmer is 2. n2 value is how much for this third series? That is going to be important for the exam. We are going to take here example Balmer series. You can take any series what we have discussed in the previous page. For Balmer series, n1 value is 2, we know it very well. n2 for third series we need to calculate, n2 for third series. So there is a trick we need to remember, that we have to add this 3 for the n1 value of particular series, and n1 value for Balmer series is 2. So for this particular line, let them ask whatever the line, that number you are going to add with the n1 value, and in that case n2 value we got 5 here. Similarly for nth line, if it is for nth line, then n2 value we can calculate by using the formula n1 plus n. n1 value we will get depending upon the series. For that you are going to add the nth line, you will get n2 value. That is very, very important. If it is for limiting line, अगर ये limiting line के लिए है, limiting line means what? The last or finest line, where n2 we can consider as infinity. If it is the last line, then n2 will be considered as infinity. in exam, if they are asking about for the shortest wavelength, what is the N2 value, or for the longest wave number, what is the N2 value. Here we have written infinity, just it's considered as question mark. In exam, they are going to ask what is the N2 value if the wavelength is shortest or wave number is longest. Similarly, they are going to ask in the exam what is the value of N2 if the wavelength is longest and wave number is shortest, because both are inversely proportional. In that case, we can able to justify, please remember this trick. If the wavelength is short, wave number is long. If the wave number is longest, then this value minus 1 by n2 square, n1 value we can easily rectify, whereas minus 1 by n square. If the wave number is longest, minus 1 by n2 square will be shortest. If this is shortest, then n2 will be highest. In that case, n2 value will be infinity. N2 value is infinity when wavelength is shortest and wave number is longest. Similarly, if the wavelength is longest and wave number is shortest, if wave number is shortest, minus 1 by n2 square will be longest. If this is longest, n2 value will be shortest. For that, n2 we can calculate by adding 1 to n1. n2 is equal to n1 plus 1 for longest wavelength and shortest wave number. This you have to remember for the exams. Similarly, let us move on to the Bohr's theory. I am not going to discuss the postulates of Bohr's theory. It is very easy around the nucleus, electrons revolving in a definite orbit and all. But one of the important point we need to remember about Bohr's theory is the maximum number of electrons in the orbit is 2n square. So according to this 2n square formula, we can calculate the number of electrons in each orbit. K shell 2L8, M18, N32. This we have to remember. Then we have to remember one more formula here to find out the angular momentum of electron in an orbit. In orbit, to calculate the angular momentum of the electron, the formula is mvr is equal to nh by 2 pi. M is mass, v is velocity, r is the radius. Here n is the number for the particular shell. Similarly, if you want to calculate the angular momentum of electron in an orbital, then the formula will be L is equal to, capital L is equal to square root of L into L plus 1 h by 2 pi. Here small l is azimuthal quantum number. By using this, we can able to find out the angular momentum of electron in that particular orbital. Then if you want to find out the radius of the orbit, then the formula is Rn is equal to A0 n square divided by Z, where Z is atomic number, n is the principal quantum number or the number of shell, and A0 value is constant 52.2 picometer. This formula also very important. And if you want to calculate the energy, formula is En is equal to minus RH into Z square by n square. Here RH value is 13.6 electron volt. If you want to calculate the energy, here RH value we have to use as 13.6 electron volt, not the previous RH value, Rydberg constant value. And velocity of the orbit Vn is equal to 2.18 into 10 to the power of 18 centimeter per second divided by n into z. This is the formula to find out the velocity of the orbit. If you want to find out the change in energy delta E, then the formula is RH into 1 by n1 square minus 1 by n2 square into z square. This is a formula to find out the change in energy. Let us one more important theory, that is de Broglie equation, which is very important to calculate the dual nature of matter. This theory to calculate the dual nature of matter, the formula is lambda wavelength is equal to h divided by mv. In place of mv, mass into velocity, we can take p, that is momentum, where lambda shows the wave nature and p shows the particle nature. Lambda wave nature of the matter and p shows the momentum, particle nature. So we can consider very important point here, wave nature is inversely proportional to particle nature. Remember, wave nature of the matter is inversely proportional to the particle nature. This you have to remember here. Similarly, we can find out the relation between wavelength and kinetic energy. Wavelength here is according to de Broglie equation wavelength. This wavelength and kinetic energy, the relation is written as kinetic energy is equal to half mv square or mv square into 2 is equal to 2 into kinetic energy. This formula I have altered. mv square is equal to 2 into kinetic energy. And to find out the value of mv, let us multiply both the sides with m. Then we get m square v square is equal to 2 into kinetic energy into m. Or also we can write mv is equal to square root of 2 kinetic energy into m. This value of mv we can substitute here. Then we got the formula h is equal to lambda wavelength is equal to h by square root of 2 into kinetic energy into m. And in that case, if the lambda is same, if the wavelength is same, then kinetic energy is inversely proportional to m. If you consider lambda as same, then kinetic energy in that case is inversely proportional to mass. Remember this. अगर wavelength same है तो kinetic energy inversely proportional to mass. And if lambda is same, then we must remember that m2 by m1 is equal to v1 by v2. Or if m is same, then lambda 1 divided by lambda 2 is equal to v2 by v1. These formulas are important to remember. Now, another important concept here is Hinsberg Principle, which tells about that it is impossible to determine the exact position and momentum of the electron simultaneously. We have this formula to find out that according to Hinsberg Principle, where delta x minus delta p more than equal to h by 4 pi or h by 4 pi m or h by 4 pi delta x into delta v more than equal to h by 4 into pi m, delta E into delta T more than equals to h by 4 pi. All these formulas are related to Hinsberg principle. Remember, where we can P is considered as m into V, P is equal to m into V, where delta x, this delta x can be considered as uncertainty in position, delta P is considered as uncertainty in momentum, and delta V is uncertainty in velocity. This is about Hinsberg principle. Now another most important topic of structure of atom chapter is quantum number, and there are 4 quantum numbers are there. First one is principal quantum number, represented by symbol n. It helps us to determine about the shell, orbit, or radius or energy of the electron. So based on the number of shells, we can give the number to principal quantum number as 1, 2, 3, 4. For k n value is 1. For L shell, n value is 2. For M shell, n value is 3. And N shell, n value is 4. And as we already learned in Bohr's theory that the maximum number of electrons is equal to 2n square. Accordingly, in the shells, we can find this many maximum number of electrons in each cell. Azimuthal quantum number, represented by small l, this help us to know about the subshell and also about the shapes of the orbital. And the azimuthal quantum number value starts with 0 to n minus 1. N is principal quantum number, 0 to n minus 1. If you are considering the value of L as 0, then it is going to signify for s orbital. If it is 1, then p orbital. If azimuthal quantum number value is 2, it is for d orbital, and if azimuthal quantum number value is 3, it is for f orbital. These values you should remember. If L value is 0, it signifies s orbital, 1 p orbital, 2 d orbital, 3 f orbital. And magnetic quantum number small m, it helps us to know the orientation of the orbital, and this can be represented with minus L, azimuthal quantum number, to 0 to plus L. If the azimuthal quantum number value is 0, for example s orbital, its magnetic quantum number also 0, because s orbital does not have any orientation because it is spherical shape. If L value is 1, azimuthal quantum number value is equal to 1, then magnetic quantum number value will be minus 1, 0, plus 1. Means what? The p orbital, if L value is equal to 1, it is p orbital, it has 3 orientation, px, py, pz. Similarly, if L value is 2, then magnetic quantum number value minus 2, minus 1, 0, plus 1, plus 2. Means if L value is 2, it is d orbital, and d orbital has a 5 orientation. Last quantum number value is a spin quantum number, where in an orbital maximum 2 electrons will be there, and 1 electron will be in a clockwise direction, another electron will be in anti-clockwise direction, represented by plus half and minus half. Now let us solve some of the previous questions which has been asked in the previous year's question paper. First question is the orbital nearest to the nucleus. The orbital which is nearest to the nucleus according to Aufbau principle must have least energy. In given 4 option, the orbital having least energy according to Aufbau principle is 4s. Least energy. That's why this is the correct answer. The correct set of quantum number for the unpaired electron of chlorine. First of all, we know chlorine atomic number 17. When we write the electronic configuration, we can find the unpaired electron in 3p. And if it is 3, then n value is n is equal to 3 and p azimuthal quantum number value is 1. So the correct order will be 3, 1. 3, 1 we can find in 4th option. So this is the right option for this. Then the energy of electron in the 9th Bohr orbit of hydrogen atom. If there is a hydrogen atom, then the atomic number is 1. And we already learned in the radius, the formula to calculate the radius of the orbit. It is minus 13.6 divided by n square into z. So as for hydrogen, z value is 1, then that's why n square should come. Minus 13.6 divided by n square. This is our not n square. So the correct option is option B. Similarly, the next question is which of the following set of quantum number not possible? So we must remember that principal quantum number and azimuthal quantum number both cannot be same. For example, here all these 3 options we can find there is a correct sequence of quantum number, whereas in last option principal quantum number value is 3, azimuthal quantum number value is 2 and magnetic quantum number value is minus 3, which is not possible. If azimuthal quantum number value is 2, then magnetic quantum number value starts with minus 2, minus 1, 0, plus 1 and plus 2. Minus 3 is not possible. So this is not possible. Next question, the 2 electrons have the following set of quantum number. We have one electron represented, one p, another one is q. The quantum numbers includes 3, 2, minus 2, plus half. Then for q, principal 3, azimuthal 0, magnetic 0 and spin is plus 5. So in that case, if we calculate this principal and azimuthal quantum number 3, 2, then it is 3d. 2, if azimuthal quantum number value is 2, we know it is d orbital. Here 3, 0 means 3 s, 0 for s orbital. So which statement is true? So it says that the correct option for here is p has greater energy than q. Both are in third shell. Both the electrons are in third shell. But when you see the orbital, q has s orbital and p has d orbital. Compared to s and d, d has greater energy. That's why this option is correct. These 3 are not correct. Next question is the statement that is not correct is, we have 4 statements. Let us go one by one. The angular momentum number signifies the shape of the orbital. Angular momentum nothing but azimuthal quantum number, and azimuthal quantum number describes the shape of the orbital. So this statement is correct. We have to find out the incorrect statement. Second, energies of stationary state in hydrogen like atom is inversely proportional to the square of principal quantum number. Just now we have learned n square. Energies of the stationary state in hydrogen like atom is inversely proportional to n square. So already we have learned the formula to calculate the energy in the previous page. Energy, see, En is equal to RH minus RH into z square by n square. So n square. So that's why square of the principal quantum number. This is also right. Then here the radius of the first orbital of helium ion is half of that of the first orbital of hydrogen atom. Again similar here, the radius of hydrogen, we learned the formula to calculate the radius, that is Rn is equal to a0 n square by z. This is for hydrogen. For helium, what in place of z we are going to substitute 2. For hydrogen z value is 1, for helium it is 2. So in that case this statement is right. The radius of first orbit of helium ion is half of that of first orbital of hydrogen atom. Whereas the statement C, total number of nodes for 3s orbital is equal to 3 nodes. Now we know the nodes are of 2 types, spherical nodes and angular nodes. Spherical nodes n minus L minus 1, and whereas angular node is equal to L. When we add these two, we will get n minus 1. So total number of nodes in any kind of orbital will be n minus 1. So if n value is 3 here, n value is 3, yeah, 3 minus 1 is equal to 2. So 2 is the right answer, but he has given 3. That's why this is the not a correct option, not a correct answer. Next question, among the elements of atomic number 1 to 36, the number of elements which have unpaired electrons in their s subshell. They have given 1 to 36 atomic number. This many elements are there. Out of these 36 elements, we need to find out the number of elements that have unpaired electrons in their s orbital, unpaired electrons. So s orbital capacity, you know, 2 electrons. Unpaired means it should be having 1s1 configuration. So we know in alkali metals, hydrogen, lithium, sodium, potassium, rubidium, you cannot consider. Rubidium is more than 36, don't consider it. So these 4 elements can show unpaired electron in the s orbital. So children, 4 is not the correct option. Out of 1 to 36, you cannot choose this 4, because in addition to that, in 3D series, you can find 2 elements having exceptional electronic configuration, that is copper and chromium. These 2 also shows unpaired electron in 4s orbital. That's why along with these 4, these 2 also we have to include. Then the correct option is option C, 6. Then the electronic configuration of copper. Already here we learned copper electronic configuration is argon 4s1 3d10. They are asking the electronic configuration of copper ion. From these 2 electrons you remove 1 electron from s orbital and 1 electron from 3d10. Then we will get argon 3d9 4s0. This is the correct option. Impossible orbital among the following. Out of these 4, impossible is 3f, because 3f is not possible. Okay, if n is equal to 3, then L is 0, 1, 2. 0, 1, 2 means if principal quantum number value is 3, then L is n minus 1. 3 minus 1 is 2. So it starts with 0, 1, 2. 0 for s orbital, 1 for p orbital, 2 for d orbital. So maximum for third shell d orbital will be present. F is not possible. For F, L value should be 3. So that is not possible for this principal quantum number. So this is impossible. 3f is impossible. Then remaining can be possible. Then the correct set of 4 quantum numbers for the outermost electron of sodium. Sodium atomic number given. You write first electronic configuration. Last electron comes in outermost electron is 3s1. Principal quantum number value is 3. For s orbital, azimuthal quantum number value is 0. So 3, 0 is coming in the 4th option. D option. This is the right one. So as we have solved here 10 questions in the previous exams, most of the questions are coming from quantum numbers. So quantum numbers are the most important one to be remembered. Thank you, children.